In today's video, we're going to be taking a look at the Motor6D's transform property, and this video is somewhat a part 3 to my two animation controller videos. One of the things we learned from the animation controller videos is that animation controllers are very performant. Now, one reason for this is that Roblox has some optimizations, one of them being client animator throttling, which essentially plays animations that are far away from the camera at a slower rate than animations that are close to the camera. Now, another reason why the animation controller is so performant is because it uses the Motor6D's transform property. And we can see in the description it says, Motor6D transforms are not applied immediately, unlike updating C0 and C1, but rather as a batch in a parallel job after pre-simulation, immediately before physics steps. The deferred batch update is much more efficient than many immediate updates. Okay, so what I've done now is created a base plate project, and let's just play the game and mess around with a Motor6D and just see how it acts. So here I am on the client side, and if I go to the server side and inside of workspace, create a new part. And inside of this part, if I create a Motor6D and I set part 0 to the spawn location and part 1 to the part that we just created. Now we can see the part went inside of the spawn location. So if I change the size of the part to 444, and let's just change the color so it's easy to see. And now we can see that this effect took place on the client side, and I can stand on this part and everything is normal. And what I could do now is, if I'm on the server side, I could change the Motor6D's transform property. Now we can't do this inside of the properties window because the property is hidden, but we can use the command bar. So if I say workspace part Motor6D.transform equals C frame, and I'm going to set it to a C frame of -20 and press enter. And now we can see that the part moved on the server side. But if we go to the client side, we can see that the part is still in the center. And that is because the transform property does not replicate from the server to the client. So what this means is now the client sees the part over here. And because I have network ownership of my character and I stand on this part, we can see that on the server side, I am floating. And if I walk over here, where the part should be, we can see that I clip into the part. And what else I could do is, if I move away from here and go back to the server side, what I can do is create a brand new part, and let's just name this part test. And I can get the select tool and move this onto the part like so. And if I go over to the client side, we can see that the part fell down, and on the server side it went through. And that is because currently this part's network ownership is set to automatic, so it will automatically give network ownership to this part to this player. So what I could do is say workspace.test set network owner nil, and that will force the part to be owned by the server. And we can now see that the server moved the part outside of this part. And if I now move it back onto the part, we can see it collides correctly. But if we go back to the client side, we can see that this part is now floating. And if we go back and move this over here and go back to the client side, we can see that it clips into this part. So what this means is we can move a part on the server side and have collision detection work correctly for the server, but not for the client. And what's cool about this is now we have the ability to have custom replication between the server and client when working with Motor6Ds. And this can greatly help us to optimize how we want to replicate data from the server to the client. Let's now make a door like my previous animation controller videos, but instead of using an animation controller, let's edit the Motor6D's transform manually in order to make the door open and close. So let's now stop the game, and let's now quickly make a door model. So I'm going to create a new model. I'm going to create a new part, I'm going to name this part frame. And I'm going to set the size of the frame to 181. I'm going to give it a brown color. I'm also going to anchor the frame, and I'm going to move the frame so it's over here. And now I'm going to create another part, and I'm going to name this part slab, and I'm going to set the size of this to 0.5, and I'm going to give this a pinky kind of color. And then I'm going to add a Motor6D, and I'm going to set the Motor6D's part 0 to the frame and part 1 to the slab. Okay, so let's now modify the Motor6D's C0 and C1 property so that the door rotates around the edge of the frame. But another thing that happened, I'm not sure how, but this model went inside of the spawn location. I don't want this to be in there, I want it to be inside of workspace, so I'm going to move this back out. And the easiest way to modify this is if I select the slab, and then if I move it so it's perfectly in the center, this edge is going to be in the center of here, like so. So now if we look at Motor6D, we can see that this is set to -3.5. And then I'm going to select the frame and move this to the left. And we can now see that this was set to 0.5. So now the door should rotate around this edge. Okay, so now that our door is set up correctly, let's create a script. And I want this script to run on the client side because I want the door to only open and close on the client side. I'm going to set the run context of this script to client. And now what I want to do is I want to set the Motor6D's transform so it just rotates. So to do this, I'm going to say script.parent.Motor6D.transform equals, and I'm going to set it to itself, and I'm going to multiply it by a C-frame dot from axis angle. And first we need to pass in a axis we want it to rotate around. I'm going to say vector3 dot y-axis, and then I'm going to give a small number like so, and I'm going to put this in a loop. So I'm going to say while true do task wait, and then I'm going to put this into the loop. And now if I play the game, we should see that the door is moving and it rotates around this edge. But if we look on the server side, we can see that it doesn't move. Instead of just rotating the transform round and round and round blindly, let's now use attributes for the model in order to set the transform's angle. So under the model's attributes, I'm going to add a new attribute, and I'm going to call it angle. And then I'm going to set this to number. And now what I want to do is I'm going to use the tween service to update the transform property. So the first thing I'm going to do is at the top of the script, I'm going to get the tween service. And then I'm going to create a tween info. So I'm going to create a tween info with a duration of 1, with the ease and style set to elastic and the ease and direction to out. I'm then going to get the model. So I'm going to be script.parent to get the model. So local model equals script.parent. And then I'm also going to get the Motor6D, which is local Motor6D model.Motor6D. Okay, so what I want to do now is this model, I want to detect when the angle attribute changes. So over here, I'm going to connect to the attribute changed signal, like so. And now, once the angle attribute changes, I want to get the angle. So I'm going to say local angle equals model get attribute angle. And then I'm going to create a tween using the tween service. So I'm going to say tween equals tween service, create, and we're going to tween the Motor6D. We're going to pass in the tween info that we created up here, and we want to tween the transform property. We want to use from angle axis, just like we did down here. And we're going to rotate on the y-axis, and whatever the angle is that we got from the attribute, that's the angle we're going to set into the tween. And then finally, all we want to do is play the tween. And now we can delete this loop because we no longer want to rotate. And if we now play the game, and if I select the model on the client side, and if I set this to 0.5, we can see that the door opens slightly. And if I set this to negative 0.5, we can see it goes in the opposite direction. But if we check on the server side, we can see that if we select the model, it still has an angle of 0 over here, where on the client it has an angle of 0.5. That is because the attribute doesn't replicate from the client to the server, but the attribute does replicate from the server to the client. So if the server changed this to a value of 1, and we go quickly to the client, we can see that the client listens to the server and opens the door. And if we go back to the server and set this to -1 and go back to the client, we can see it moves the other way. So now the server can adjust the angle and the client can also adjust the angle, but the animation of the door opening and closing is only done on the client side, not the server side. One problem you may face is if we have some server-sided NPCs and you wanted these NPCs to walk through the door, they wouldn't be able to walk through because the door is in the way. But on the client side, the door won't be in the way. So for instance, if I set the angle to 2, now the player could freely walk through the door. But on the server side, the NPC won't be able to freely walk through the door. So there's a few ways we can go about solving this problem. The first way is, let's rename this script to client, and then let's duplicate the script and rename it to server and change the run context to server. And let's get rid of tween info, and let's get rid of all this as well. Let's just comment it out for now. And let's just say motor6d.transform equals cframe.new, and we could just give it a cframe like 0, -100, 0. And if we now play the game, so what we should see is that on the client side, the door still exists, but on the server side, there is no door. And that's because the door is all the way down here. So now NPCs can walk through the door, even though the client can't. And if we go back to the server, select the model, change the angle to 2, we can see that this has no effect on the server side. But if we go to the client side, we can see that the door opens and closes like normal. Another option we have is, instead of moving the door all the way down to -100, we can make it work somewhat like the client side. So let's bring back this event on the server side, but instead of using the tween service, let's just move the Motor6D's transform instantly to this angle. So over here, I'm going to say motor6d.transform equals, and I'm going to set it to this angle instantly. And now I can delete this. So now on the client side, we're going to be using the tween service, but on the server side, we're not. So what that means is, if we play the game, and if we go to the server side and we select the model, and if we set the angle to 1, we can see it moves instantly. We change it to 2 and go to the client side. We can see on the client side it will move smoothly to the angle we want, where on the client server side it will efficiently just teleport to the angle we want. So if I change this to -2 and go back to the client, we can see we can walk through. And also on the server side, NPCs will also be able to walk through because the door has moved to the correct angle. So hopefully this demonstration has shown us how we can use Motor6Ds to optimize our network data usage. But this demonstration does not show us how performant the Motor6D is with CPU usage. So let's now make another benchmark in order to test to see how performant a Motor6D is compared to bulk move. So what I've done is created a brand new baseplate project, and in this project I've created two scripts, one called bulk move 2 and one called motor. Inside of the bulk move 2 script, all I'm doing is looping from -70 to 70, then from -20 to 20. I'm doing the same on the motor script. Then I'm creating a part. I am setting the size to the same on both scripts. I'm parenting them to the workspace. Now the difference on the bulk move script, I'm anchoring the part, where I'm not anchoring the part on the motor script. And instead of setting the C frame like on the here, I create a Motor6D for each part. And then I set the part 0 to workspace terrain. Now because terrain is a base part, we can treat it like a part, and the terrain's position is at 0, 0, 0. So whatever C frame we set the transform, that's going to be the C frame of this part. So instead of setting the C frame over here like this, over here we set the C frame like so. And then we set the motor's parent to the part. And then we connect to the pre-simulation event on both scripts. And then we loop through all the C frames that we stored in this C frames array. And we update the C frame array to store the C frame plus the look vector multiplied by 0.1. And we do essentially the same thing on the motor script. We loop through every motor and we say motor transform equals motor transform plus the look vector multiplied by 0.1. The only difference is on bulk move, we must call this to update all the parts with this array of C frames, where on the motor script, we don't have to call any functions. Okay, so let's now test these two scripts. So what I'm going to do is move this over here, and then I'm going to enable bulk move, and this is running on the client side, but I'm going to keep motor disabled, and then I'm going to press play. And if we look at the average CPU time at the top right, we can see that it should average to around 28. So if we let it settle in for a little while, we can see 27.8, 28.4, 27.9. So it's roughly around 28. Okay, so now I'm going to enable the motor script, which also runs on the client side, and I'm going to disable the bulk move script, and I'm going to press play and check the average CPU time once again. So let's give it a bit of time to settle in. So we can see 27, 28, 26, 22, 25, 25, 25, 25. So it's roughly around 25 compared to bulk move was 28. So it's around 2 to 3 milliseconds faster than bulk move. So there we have it. Motor6Ds are ever so slightly more performant than using bulk move 2. But another big benefit of Motor6Ds is code design, especially with object-oriented programming. For instance, let's say we had an object, and this object is called self. And let's say this object has a property called motor, and this motor property will point to this Motor6D instance. Then in order to move this object, all we need to do is set the transform property to the C frame that we want to move this object to. But it's not so simple when using bulk move 2. First, what we need to do is have access to these two arrays, the parts and C frames array, and then we need to do table.insert parts, and we need to insert the object's part. Then we need to insert the C frame that we want this object to move to, like so. And then we're going to need to call bulk move 2. But this is where a small problem happens, is we can't call bulk move 2 instantly because there may be some more objects we want to move. So we need to schedule bulk move to take place before the simulation. So once we've scheduled bulk move to take place, we move all the parts, and then so that the parts don't get moved in the next scheduled bulk move, we're going to need to clear these two arrays. So we have to do table clear, and we're going to clear the parts, and also we have to clear the C-frames. So you can see it's a lot more complicated work with bulk move compared to Motor6Ds. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.